Hi, this is Babak. In this video I'm going to solve the following problem for you. The problem is in single variable calculus on the topic of calculating a limit using the definite integral. Let me read the problem for you first. Let f of x be this limit for all x greater than 0. Which one or ones is or are true? So you see that we have four choices here. We want to choose all possible correct answers. This problem has been chosen from JEE Advanced Paper 2 2016. JEE is a very tough entrance exam for Indian universities for technical and engineering programs. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do it correctly, finally you will find that the choices B and C are the true ones and A and D are the false ones. Okay, now let us start solving the problem together. The main theme, as it is mentioned here, I want to use this formula to calculate the limits. So if you have studied one variable calculus at this level, you will realize that we have a formula. So if I want to calculate a limit of 1 over n sigma of f k over n, when k goes from 1 to n, when n goes to infinity, if f is a continuous function, this becomes the integral from 0 to 1 of f of x v of x. So that is the main theme of solving this problem. But of course we have to work a lot to make the problem in a way to look something that I can use this formula to solve the problem. But here, because x is already been reserved here, so let me write this formula instead of writing it in a different with a different variable. So let me just choose it. For example, let me write this as integral from 0 to 1 f of y d of y. Okay, so that's a very famous formula that is very helpful if you want to calculate a limit of this particular form. You can calculate instead this definite integral on the interval from 0 to 1. Okay, so now let us see how we can use this idea. Before doing anything, it would be very helpful if I simplify the form of this function that is here. So for simplicity, let me just call this function here to be g sub n of x. Okay, and then I want to simplify this a little bit. So how do I do that? So what my goal is to factor an n out from here, an n out from here, and finally an n out from here. So I will take n outs each from one pair of brackets. Okay, so g of n of x can be written in this form. I have n to the n in the numerator. I pull one n out from the first pair of brackets, so it becomes x over n plus 1. So what I am doing, I am pulling this n out. I have written it here, and this expression becomes x over n, and the next one becomes 1. I will do the same thing. I pull an n out from here, so then it becomes an n again here, and then I will have x over n plus 1 over 2. Yes, and then this will continue. I will take another n from the very last pair of brackets. It becomes x over n plus 1 over n. This would be my numerator, so I can write it a little bit closer now. Yes, and in the denominator I want to do more or less something similar. Okay, so I will have an n factorial here, but this time I want to factor an n squared from each pair of brackets. So then I will have n squared out from the first pair of brackets, so it becomes x squared over n squared plus 1. So you see that I am pulling n squared out, so this n squared is here, this becomes x squared over n squared, and then this becomes 1. And for the next one I will do the same thing, but of course it becomes x squared over n squared plus 1 over 4, and I will and then I have another n squared here. Then I will continue until the very last one, so it becomes x squared over n squared, and then I will have 1 over n squared, yes? And then this will also go up to n squared. And then I will have this to the power of x over n. Okay, now let us simplify this. So what happens here, I have n multiplied by itself n times, so it becomes n to power n, but there is another n to power n here, so it becomes n to power 2n. And then if you see here, I have n squared multiplied by itself n times, so it's also n to power 2n. And this n to power 2n and then n to power 2n are gone. So what's happening is actually all these factors and all these factors now are gone. For me, there is an n factorial left. What I do, I write it in this form: 1 times 2 times 3 times 4 up to times n. I will take the first one and multiply it here. I will take the second one and multiply it here, the third one and multiply it by the next one, and finally I will take this one and multiply it to the end. Okay, and let me write it down now. What will happen in the numerator, now I will have simply x over n plus 1, and I have x over n plus 1 over 2, and then I will have x over n plus 1 over n. In the denominator, as I described for you, the first one becomes 1 times, of course, this is, I'm just writing it formally here. So this becomes 1 times 1. The next one becomes 2 times x squared over n squared plus 1 over 2, yes? And then what happens is, if I continue, the next one becomes n times x squared over n squared plus 1 over n. So what I did, as I told you, I wrote it as 1 times 2 times 3 up to times n. I took this one multiplied by the first pair of brackets. I took the other one multiplied by the second pair of brackets. So you see this is multiplied by 2. This is also multiplied by 2. And then finally I will take the last one n and multiply it here. So you see that I have these things. The reason this is 1 over n because this n that is multiplied here and this one are cancelled, and I will get that one. And of course I will have that one again on top of that. This power, yes? X to the x over n. Now, of course, you are very familiar from your calculus course that if you want to calculate a limit, that you have this 0, because when n goes to 0, the exponent is 0, and then you immediately realize that you need to take ln from both sides. Okay, so I will take ln from both sides if you have already learned these techniques when you were dealing with calculating these sort of limits. So I take the ln from both sides, then this will go down. It becomes x over n, and it becomes the ln of the numerator. So x over n goes down, so I need to take the ln of the whole fraction. The ln of a fraction is the ln of the numerator minus ln of the denominator, but ln of the numerator can be written as the sum of the ln of each individual terms, yes, because ln of the product is the sum of the ln's. So then it becomes sigma ln of x over n plus 1 over k. K goes from 1 to n. And then I will have minus sigma, k goes from 1 to n, ln of k times x squared over n squared plus 1 over n. Okay, so that is the ln of gn of x. But still, I can simplify this a little bit more. So this becomes x over n. Here, again, you see my goal is to make something like this here. I want to have this combination. For 1 over n, I do not have any problem because I have 1 over n here. So I can multiply it here and there. But then I have to write this as a function of k over n. This is still not exactly in that form, so I have to make it like that. So what can I do? It's not hard to see what we can do here. So I can take this one and I would write ln. From the pair of brackets I can factor 1 over k out, and then what is left for me is k over n times x plus 1. Yes? So that is what is actually written there. So let us convince ourselves again. So if I multiply 1 over k here, it becomes x over n, which is the first one. If I multiply 1 over k here, it becomes 1 over k. That's correct. Okay, but the same thing I can do here. I can factor 1 over k out from here, so this becomes the sigma. K goes from 1 to n. I have ln of 1 over k, and then I have k squared over n squared x squared plus so I made a mistake when I was writing this. This is not n, this is k. This is supposed to be 1 over k. Because if you see, this is first 1 over 1, and then I have 1 over 2, and then I have 1 over n, so it is 1 over k. And then it means that this becomes 1 when I factor this out. Yes? Okay, and then I have this pair of brackets closed at the very end. But again, I have the ln of the product of two numbers. I can decompose them into the sum, and I can also decompose this sigma into two sigmas. Yes, so this becomes x over n, and then I have sigma ln of 1 over k. K goes from 1 to n, plus sigma k goes from 1 to n ln of that expression k over n x plus 1. And then for the next one I will do the same thing, but there is a negative sign behind, so it becomes negative sigma k goes from 1 to n ln of 1 over k minus sigma k goes from 1 to n ln of k squared over n squared x squared plus 1. Yes? So that would be the expression that I have. But now the interesting thing is here that this expression, whatever it is exactly equal to that one, so they are cancelled because one of them is positive and the other one is negative. And then I will have these two. And now what I do, I will multiply 1 over n inside. So what happens? It becomes x. Sorry, let me change the color. So this becomes x, and then it becomes 1 over n sigma. Let me write it in this form, ln of 1 plus k over n x. K goes from 1 to n. The other one is 1 over n sigma ln of 1 plus k squared over n squared x squared, and then k goes from 1 to n. Yes, so that's the expression that I have for the ln of g of x. Okay, so let me just take these things with me to the next page. Okay, so I copy this, and that is equal to ln of gn of x. Okay, so I will go to the next page. Let me paste it here. So it is not working, I don't know why. So let me try another time. Okay. So this is the ln of gn of x. Okay, now I will take the limit from both sides and send n to infinity. So x is a constant here, so I need to concentrate and calculate this one. But that is exactly the right form. You see, I have 1 over n, I have a sigma of f of k over n. Yes, k goes from 1 to n. Here, f of k of n is this expression. So it is very clear that if I ask you what is f of y here, you would say, what is your function? Your function is ln of 1 plus k, x times y. Yes, that is your function. Don't get confused here. This is the reason that I wrote it here. Let me just repeat it here. I was foreseeing what's going to happen. This is why I wrote everything in terms of another variable, even though the common variable is the x variable. Okay? Because x is already reserved here, so I am just using a variable. So as soon as I have a limit of this form, I can write it as the integral from 0 to 1 of that function here of y times dy. Okay, so I will do the same thing here. So this becomes the integral. So x is just x. This limit inside, the limit of this part, becomes the integral from 0 to 1 ln of 1 plus x times y dy. And the other one becomes minus integral from 0 to 1 ln of 1 plus x squared y squared dy. Yes, so this is the limit of this function. Okay, but I can simplify it a little bit. So I can multiply that x in, so this becomes integral from 0 to 1. This becomes ln of 1 plus xy, but this is a constant as far as this integral is concerned because the integration variable is y. So I can multiply this x inside the integral and I can write it here. Okay, and then I will have the same scenario for the second one. So this becomes ln of 1 plus x squared y squared, and then I can write it as x dy. The reason that I am writing it in this y because I want to change the variable. In the first and second integrals, in both of them, I can take xy to be my new variable t. Then I differentiate both sides, but remember the y is the integration variable here, so this becomes x dy on the left hand side. On the right hand side I will have dt, and that is the reason that I wrote it in this form, because now this one is dt and this one is dt. But what are the limits of my integral? So the integral y was going from 0 to 1. This would imply that t goes from, if I put y equal to 0 here, t becomes 0. If I put y equal to 1 here, t becomes x. So this goes from 0 to x. So this means that the limit of ln of gn of x, n goes to infinity, is equal to integral from, instead of 0 to 1, I would write from 0 to x, ln, instead of 1 plus xy, I just write 1 plus dt, and instead of x dy, I simply put dt, and for the second integral, exactly the same. Okay, so this is the limit of this function. So it means that if I ask you what is the limit of gn of x itself, which is my function by the way, because if I go back here, if I ask you what is f of x is the limit of gn of x, not ln of gn of x. Okay, so here this means that the limit of gn of x would be exponential of this function. Yes, so actually I found my f of x. So f of x is this expression. So this is what I got here. Exponential of this is my function f of x. Okay, so now if we can do it in this way. We can take an ln from both sides to get rid of this exponential function. So f of x is definitely this one, but for this problem, it would be better if I take ln from both sides here. So this becomes ln of f of x, but ln of an exponential function becomes the this expression itself, because ln will cancel exponential. So this becomes this. Okay, so this is the expression that I get for this. Let me make it a little bit nicer if I can. Okay, so this would be the ln of this function, and let me copy this and take it with me to the other side. Now I put it here, and then I will try to check the each one of these. This is ln of x, sorry, so this is ln of x, yes, this is ln of x. Okay, now for example, checking this shouldn't be hard, because you see that I have this combination, and hopefully you immediately realize that I need to take the derivative from both sides, because the derivative of the second of this one is exactly of this form, f prime of x over f of x. So let me just do that. I will take the derivative from the left hand side. It gives me f prime of x, and on the right is f prime of x over x. On the right hand side I need to use this formula, and hopefully you remember this from your calculus courses. If I have an integral from a to some x f of t dt, and if I want to differentiate it with respect to x, the answer is just simply f of x. Okay, that's the first fundamental theorem of integral calculus, yes? So I do the same thing. So here I want to take the derivative of this function, so this becomes ln of 1 plus x minus the second one becomes ln of 1 plus x squared. So this means that f prime of x over f of x is equal to ln of 1 plus x divided by 1 plus x squared. Okay, now I want to check this one and this one, how they are related. So it is clear. So this means that let me calculate f prime of 3 and f prime, let me replace x with 3. This becomes ln of 4 over 10, which is equal to ln of 2 over 5. And if I calculate f prime of 2 over f2, it means that I have to replace x with 2, so this becomes 5. And then it is clear that ln is an increasing function, so 2 over 5 is smaller than this, so this means that this should be smaller than that one. So this, it definitely tells you that the d is wrong, yes? So we know that according to this calculation, this is definitely less than this expression. So d is wrong, yes? So let me write d is false. Okay, and then, by the way, we can also check immediately this one is true. Why? Because you look here, I found this expression, so this means that if I ask you what is f prime of 2, you would say that f prime of 2, but by the way, what is f of 2? If I go back here, you see f is an exponential function. So if I ask you what is f of 2, it is an exponential of something, yes? So this f of 2 is positive, definitely. Okay, so, but what is this number? 3 over 5 is smaller than 1, ln of a number is smaller than 1 is negative, f of 2 is positive. So this tells me that f prime 2 is definitely negative. When a number is negative, you can also conclude that f prime of 2 is less than or equal to 0. So this means that C is true. So C is true. Okay? Now, what about these numbers? So what about this option and that option? Okay, so here what we can see is that from here I can multiply everything by f of x. What I get is that f prime of x is equal to f of x multiplied by ln of 1 plus x over 1 plus x squared. Okay? But what is the derivative of this function? So you see that on the interval from 0 to 1, for all x's in this interval, ln, so here when I am working in this interval, 1 plus x squared is smaller than 1 plus x. Yes, because if x is between 0 and 1, x squared is definitely smaller than x, and of course positive. This means that I have a fraction whose denominator is smaller than its numerator. So it means that this is a number greater than 1, and ln of a number greater than 1 is positive. Okay, so this part is positive. And f of x is an exponential function. This is also positive. So it means that on this interval, it is guaranteed that the function the function is increasing. Okay, so I would say that f is increasing on the interval 0 and 1. Okay, so then what does it mean? Here you see that when the function is increasing, you know here 1 over 2 is smaller than 1. So, and the function is increasing on that interval, so it means that f of 1 over 2 should be less than or equal to f of 1. So this means that a is also false. Yes. And then the other one, 1/3 is less than 2/3 in the interval from 0 to 1. Yes. So we have 1 over 3 is strictly smaller than 2 over 3, but because the function is increasing, this means that f of 1 over 3 is less than or equal to f of 2 over 3. So then this means that B is true. And this will finalize the solution to this, I would say, very hard problem for the entrance exam. Okay. I hope that you enjoyed the problem. I will put a link to the PDF file of these notes below this video. Until the next video, be safe and goodbye.